Lesson 3, we're going to talk about piecewise functions. Now, a piecewise function is simply a function that is made up of at least two different functions and their pieces, hence the name piecewise function. Now, one of the biggest things you're going to be asked to do in Math 3 is to evaluate a piecewise function. So when you're given a specific x value, you want to find what value, okay, or like when you evaluate it, corresponds to it. To get this answer right, you have to use the matching piece or function when evaluating. So like this doesn't really make a whole lot of sense, but as we go through these next 3 examples, should hopefully make a little bit more sense. Now, piecewise functions, I have a very, very big function, f of x. Then I have 3 smaller functions that make up f of x. I personally like to give these names a, b, and c of x. Okay. F of negative 1. So I can evaluate the function f of x at -1 when it matches or corresponds to either piece A, piece B, piece C. Now, how do I know which function it matches? It's going to tell you based off of what number you're going to use. So -1, where does it fit inequality-wise? So if I plug -1 in A, B, and C, I want to find the true statement. So -1 is less than -2. Is this true or false? Again, 0, I have -2. -1 is to the right of 2, so this is false. So it's not going to go here. Now, -2, x is greater than -2 and less than or equal to 4. So can -1 fit in this area right here? Sure, right? Because it's bigger than -2, but it's also less than 4. So what this tells me is that -1 fits b of x. So, which is equal to 2x minus 1. From here, again, I want to plug in -1. So 2 times -1 minus 1. 2 times -1 is -2 minus 1. Be -3. So the hard part is finding which inequality and which piece of function your given x value corresponds with. So this time I have -4. So is -4 less than -2? It is indeed. So it must be this one. So it must be a of x. Then a of x is equal to x minus 1. A of -4 is equal to -4 minus 1, which is -5. And then last but not least, again, each time you evaluate, it's only going to have one piece that your given x value can correspond with. So f of 5 is really c of x, and c of x is really -3x plus 8, and I'm going to do evaluate C of 5. So negative 3 times 5 plus 8. Negative 3 times 5, negative 15 plus 8 makes that negative 7. Okay, so this is how you evaluate piecewise functions. On page 23, I try and complicate it just a little bit more by throwing in extra operations. You can also have a word problem. I'll do number 1. Okay, so h of x is this big function to the right. I want to focus on this negative 1. So where does negative 1 fit? Again, I'm going to call top function a of x, bottom function b of x. Is negative 1 greater than 0? No, it's not. Is negative 1 less than 0? Yes, it is. So therefore, I'm going to use this piece, b of x, to evaluate this. So 5b of x is really 5b of negative 1, which is just 5 times negative 2, and again I'm evaluating it at negative 1 minus 2. So again, order of operations, inside parentheses first. Negative 2 times negative 1 is 2. Minus 2. 2 minus 2 is 0. 5 times 0 is just 0. All right. So again, piecewise functions, a little unorthodox, but it's not bad. Again, start off by figuring out which piece of the bigger function can or does the given x value fit. So like 0 is not less than or equal to negative 2, so it doesn't fit the top one. Therefore, it must fit the bottom one. Okay. Negative 9 is less than or equal to 0, so it must go to this one. All right, and I'll let y'all do the last ones.